What's up, my trig learners? We're in section 13.2. We're going to be talking about general angles and radians. Remember that radian mode you have on your calculator that you don't really know is what it is? We're going to be talking about what that is. And more importantly, what we're going to spend the most time on is how can I talk about angles that are bigger than 90 degrees? Because right now, we have only been dealing with right triangles. And you know that when you're dealing with right triangles, these angles are always smaller than 90 degrees. How can I talk about angles that are bigger than 90 degrees? And the answer to that is this. We need to talk about the angles being in standard position. So here's what we're going to do. Especially useful for angles that are bigger than 90, we're going to put them in standard position. And in standard position, we're going to put them on a coordinate plane, okay? So we're putting it on a coordinate plane. There's my x-axis and my y-axis. We're going to put the initial side right along the positive x-axis. So when an angle is in standard position, we put kind of one of the rays that make up that angle right on the positive x-axis. And then we're going to spin a little bit, okay? So from here, we're going to spin to wherever the angle belongs. So let's say we spin 45 degrees. Here is our angle. This second side that I just drew is the terminal side. Let's say we want to spin 180 degrees. So that would be thinking like this, right? That's a straight angle. But let's say I even want to go past 180 degrees. Let's say I want to go to, let's go crazy. Let's go to like 290 degrees. So let's think about what's going on here. Spinning this much is 90 degrees. Spinning this much takes me to 180 degrees. If I go another 90 degrees, now I'm at 270. My angle is just a little past that. So this, if I go the whole way around, is a 290 degree angle. Pretty cool, huh? We could also do negative angles. What do you think negative angles will be? Well, negative angles would be if I'm spinning instead of counterclockwise, if I start spinning clockwise. So let's say I do negative 50 degrees. That would be spinning this way. This is considered a negative 50 degree angle because I started spinning clockwise. Okay, so hopefully that gives you a good introduction. Let's practice these techniques. We're going to draw each of the following angles in standard position. So, first of all, let's draw our little coordinate planes for each of these angles. Oh look, negative 50 degrees. I just drew that angle for you. Maybe I had some premonition. We know that negative 50, we are spinning in the clockwise direction. So here's a negative 50 degree angle. And yes, I do want you to draw this little spiral inside. Spirals make me pleased with you. Let's draw 240. Okay, so I know that this much is 90, this much is 180, and 240 is only 60 past 180. So not all the way to 270, which is down here. Maybe somewhere like here. Something like this. This looks like about 240. I'm not quite to 270, which is kind of the negative y-axis or the third 90 degree. Okay, 500. Whoa, this is crazy because notice if I went all the way around, wouldn't this be 360 degrees, right? Like you've heard 360 degrees in a circle. This is kind of where it comes from. But I actually need to go 500. So I actually need to keep going. This would be, what's 90 plus 360? This would be 450, right? Because I just went an extra 90 degrees. And then I only need 50 more degrees, so maybe something like here. That looks about right. And notice how the spiral went the whole way around. Now notice, this is exactly the same angle as if instead of going the whole way around, I just went like this. Or what if I was thinking negatively and went like this? In other words, there are some angles that give me the same looking angle. And this is what we call coterminal angles. They share the same terminal side, or in other words, they look the same. So let's think about this 240-degree angle I drew here. So up here, I went around positively. But for a coterminal angle, what if I had gone around negatively? And how much would that be? Well, wouldn't that kind of be like subtracting 360? If I subtract 360, that would be negative 120. So negative 120 is a coterminal angle. Or what if, instead of just going once around, I actually went like twice around? So what if I went, whoop, now I'm at 360, and then I went around to the 240? Wouldn't that kind of be like taking 240 and adding 360 degrees? In other words, arriving at 600 degrees? So this is another coterminal angle. So notice that if I'm subtracting or adding 360 degrees, this is where I get coterminal angles. So let's think about the minus 50 degrees. Yes, I could go directly there. But what if, thinking negatively, I went the whole way around and then went another 50 degrees? So that's like negative 360 plus the 50. Wouldn't that be like negative 410? So this is a coterminal angle. Or what if, instead of going the whole way around negatively, I just went around the positive way? That would kind of be like adding 360. And that would give me 310 degrees. So I think you get the point. We'll skip 500 for now because I already kind of introduced that. Just know that in order to get coterminal angles, basically we just need to add extra spins or take away extra spins or do extra negative spins. In other words, I can add plus or minus 360. And yes, just so you know, if you kept adding 360 to get up to 960, wouldn't that also be a coterminal angle? Like now it's starting to get crazy. Once around, twice around, and then to the 240. So you can just keep adding or subtracting 360 to get coterminal angles. Pretty cool. All right, so we have one more thing in the essential question, which is to talk about radians. So as we just talked about, we know that in a circle, if you go the whole way around, that's 360 degrees. But I know another way of thinking about circles, and that is with their circumference. Remember, the whole way around a circle is called the circumference. And if you remember from geometry, there's a very specific formula for circumference of a circle, and that's c equals 2 pi r. So that means that if this circle had a radius of 1, the circumference, when I plug in 1 for r, would just be 2 pi, right? 2 pi times 1 is just 2 pi. That means the whole way around is 2 pi. So in other words, I could think of the whole way around this circle as 360 degrees, or, and this is what radians are, if we think in terms of radians, it's thinking more like the circle. You kind of see the word radius in there. And with a circle, it's 2 pi to get the whole way around. So radians are this different way of measuring angles where I'm measuring in terms of 2 pi being the whole way around. So how do I convert between degrees and radians? Well, I can use the conversion factor 360 degrees over 2 pi, which actually simplifies, if I simplify the 2 and the 360 degrees, this simplifies to 180 over pi. So let's think about what some of these angles look like. If I know that pi is, well, how does this relate to 2 pi? If 2 pi is the whole way around, wouldn't pi be half of the way around? So here is my angle. It's pi. It's half of the way around the circle. And notice when we did our conversion factor, we knew that 180 degrees and pi were equivalent. Interesting. So how about negative 2 pi over 3? I have no idea how to think about this. So let's put it in terms of degrees. Now, since this is in radians, and pi represents my radians down here, in order to cancel the radians, let's use a little factor label technique. I hope you saw this in chemistry. If I multiply by 180 degrees over pi, that will cancel the radians and leave me with degrees. So I'm going to multiply by 180 over pi. That will cancel the radians and leave me with degrees. So let's simplify here. I can cancel the pi. I can reduce 180 and 3 to 60. And now I just have negative 2 times 60, which is negative 120. The degrees stay because although the radians were canceled, the degrees were not. So this is negative 120 degrees. That angle, remember I'm moving negatively, so it looks something a little past 90 degrees, something like this. This is negative 2 pi over 3, which we decided is the same as 120 degrees. Now I'm guessing some of you are just watching this without the volume, in which case my warning will go unheard, but this is a kind of confusing concept. You might want to go back and rewatch it just to like kind of let it sink into your head, this thing where it's a different way of measuring the whole way around. I could either say 360 is the whole way around, or I could say 2 pi is the whole way around. But some of you just rush through these videos. Maybe not the best thing to do. Let's call it for today, right after I tell you how to find coterminal angles. Now, we remember with degrees, finding coterminals was as simple as adding extra loops, which meant adding or subtracting 360 degrees. So for radians, we're still adding an extra loop or taking it away, but here, remember the loops are 2 pi. So in order to find coterminal angles here, I'm going to add or subtract 2 pi. So let's say I have my pi angle. That looks like this. A coterminal angle, well, if I subtracted 2 pi, that would leave me with negative pi. And wouldn't that just be going in the negative direction? Oh, look, it's coterminal. Or what if I added 2 pi? That would be 3 pi. And wouldn't that be, I'll show this in red, going once around and then an additional pi, right? This 2 pi plus an additional pi, that would be 3 pi. So just like with degrees, you can find coterminal angles with 360 degrees, adding or subtracting. With radians, you can add or subtract 2 pi. All right, so we learned a lot about angles today and radians. It's simple, I promise. It's just weird, right? So you just need to get used to it. If you're a little confused, I actually feel like I was decently clear this video. Sometimes I'm not always. Go back and rewatch. Just kind of digest it and think about these things. Thanks for watching.